very good morning. So, wherever you are, let me welcome you to this course whose title is Laser Fundamentals and Applications. So, this is a 20 hours course, and this course is basically intended for undergraduates or those people who want to learn the basic or fundamentals of lasers and their applications. But nevertheless, those people who have some already have some basic idea about laser, this course can benefit them as well, because toward the later part of this course we'd like to cover certain applications. Some of them will be state of the art applications which are quite advanced in nature. So, there will be food for everyone pretty much. So, today is the first day of this lecture series, and let's start this topic by asking the very fundamental question, that is, why should we study laser? Why should anyone study laser? So, the question that we ask first, why laser? Now, the laser is probably one of the most important inventions of the last century, if not the most important invention. So, when I say that, that pretty much answers that why should one study the laser. If I want to answer it a little bit more explicitly, then what I should say is, the answer is that it is important to because of its unique properties. Okay, so unique properties of laser, which leads to very unique applications. So, anything, any invention or discovery becomes really important when it actually leads to certain applications in practical life or in real life. Okay, then people like to know more about that particular topic or the particular thing. So, when I said that the laser has unique properties, so what kind of unique properties? We will talk about those properties in greater detail as we progress, but let me tell you a very few things. Excuse me. So, when I talk about this unique properties, we can name a few. First is this laser light has a property which is called monochromaticity. That is, the laser light has a very narrow line width. If I look at the spectra of any laser output, it will be really narrow. So, that is called a monochromatic radiation or near monochromatic radiation. So, depending on what kind of laser one is looking at, can get a really monochromatic radiation, which is big advantage if you want to do certain kind of applications. Okay, be it a fundamental type or be it practical real life application. Second thing is that laser light is coherent in nature. So, when I say this term coherent, that means that all the photons coming out from laser has the same phase. So, all the photons, when they have same phase or they are in phase, we call that light beam as a coherent beam. This is a huge advantage. okay, which is not available in all other light devices that gives different types of light, different wavelengths of light, different frequencies of light. But laser gives rise to this coherent beam. The laser gives a light we often call laser beam. Why? Because this comes out like a collimated beam. So, the laser light is collimated. Moreover, they have directionality. Okay. They can be highly tunable, meaning that I can start from one particular wavelength and I can go to a different wavelength and I can scan through a huge range. Okay. So, this is called tunability. So, this tunability is a huge advantage for any light source. And another most important properties of these lasers are that they can have really high power. So, the energy density of the laser beam is extremely high. Okay, there are different terms used for that. One can use a term called fluence, which measures this, in other way, the power of the laser beam. So, one can have very high power, average power, or there is something called peak power, which we will discuss more and more in detail. So, these lasers can be having really large or high power, which can be used in different industrial applications, like one can use it for cutting or welding, melting various different materials. So, these are certain unique properties of this laser, and as you can understand that if some light coming out from some device due to certain processes have this particular set of properties, they can be used in various different things. Now, when I say that it can be applied to various different sectors, what do I mean? How wide is the range of applications? So, let's look at that. So, let's name a few of the applications. So, applications of laser. Now, laser can be applied in various different sectors, as I said earlier. So for example, it can be used in scientific applications. It can be used in medical science or medicine. It can be used in industry or commercial purposes. It can have applications in defense, and there are many more different sectors that we can name. Essentially, if you think of any particular area where you look for an application of a device, laser is a device which can probably find application in all those areas. This is so versatile. So, let me give you a bit glimpse about what are the different types of applications in all these sectors, like scientific sector, or medical science, in industry, or in military science, what are the different types of application that one can achieve using lasers. So first let's talk about the scientific. Okay, scientific applications. So there are varieties types of scientific projects where laser can find these applications. Let's first start with something called spectroscopy. Most of you perhaps know what spectroscopy is. It is a subject area where it deals with light matter interaction, right? So this particular topic can give information about molecules or materials, their structure, their properties, and various other things. Now there are various different kinds of spectroscopy, and laser finds their applications in pretty much all the different types of spectroscopy that you can think of, okay, except a very few. So one of the largest contribution of lasers in this domain of spectroscopy is probably the nonlinear optics. Where people generate newer frequencies by combination of different input frequencies. We will talk about nonlinear optics in quite detail at a later part. And we have Raman spectroscopy. We know Raman process is a very weak interaction of light with matter, and you need a really high intensity light source to obtain Raman spectra. So laser had made Raman spectroscopy really easy in that sense, because it can provide really high intensity of light. There is something called laser induced breakdown spectroscopy. Various super resolution spectroscopy can be obtained using laser. Why? Because earlier we mentioned that it can be really a monochromatic light source, right? So if I want to have a very specific transition from one state to another in a particular molecule, so I need to have a specific frequency of light or specific wavelength of light, and that can be achieved using laser, a high monochromatic beam. So super resolution spectroscopy can be achieved using laser. Various different interferometric technique can find laser applications. So if I think about microscopy or imaging, so if I talk about microscopy and imaging, today's microscopy, particularly optical microscopy, cannot be thought without the use of laser in it. So you name any optical microscopy, laser is used. If you talk about confocal microscopy, you need laser. You want to have multiphoton microscopy, you definitely need laser. Without laser you cannot have multiphoton microscopy. And many of you may be aware that multiphoton microscopy is one of the wonderful tools today that people use in biology, medicine, material science, and why not. The latest Nobel Prize in the field of optics and microscopy went to Morner, Stephen Hell, and Brzezik. So they got this Nobel Prize because of the invention of super resolution microscopy. Now, super resolution microscopy or imaging could not be achieved without having the laser in hand. Okay, so super resolution, when we called super resolution microscopy here, it essentially points to the spatial resolution, that is how 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 you can separate 2 points in space, okay, which are very close enough. So if you can resolve 2 points in space, then you have a certain resolution. Now, if I bring these 2 points very close to each other, you may not be able to resolve that, and 2 points may appear to be a single point. Now, if you have a technique which can give you the ability to resolve even that extremely closely spaced points, you essentially achieving something called super resolution. Okay, this is a very gross way of saying this. We will talk about it in detail. There we will explain what super resolution technique is. Okay, and there are other microscopic techniques which are being used very often in industry, and particularly medical industry, is called optical coherence tomography. You need a laser to do that. There are other areas in scientific research where without laser you are almost you cannot do much. So what are those areas? If we can start looking at that, if you talk about astronomy, you have laser application. Astrophysics, geology, seismology, space technology, remote sensing, where you find application of laser in a particular way in terms of LIDAR. Lasers are used to do a particular form of cooling atoms or molecules, which is called laser cooling. So of course you can understand without a laser you cannot have laser cooling, and this is of paramount importance in certain research areas. There are certain other areas like nuclear fusion, where laser is being used now. So you know that nuclear fusion requires a very high amount of energy. So laser, as we said, that can provide very high power light beam, and this high power light beam, if it is concentrated, one can actually produce a huge amount. It's it's rather humongous amount of energy, which can even lead to nuclear fusion. Okay, so you can you can guess that how vast is the application, and I have just talked about a few topics under scientific research where laser finds its application every now and then. And basically, if I tell you the truth, without laser most of these scientific topics would not be possible to deal with. Now, if I look into the application of lasers in the field of medical science or medicine, so medical application, what you can think of, many of you probably know, many of your relatives, parents, or teachers, friends might be telling you that, okay, I have gone through laparoscopy. Okay, so these laparoscopic surgeries are also assisted by laser. So first place, there are in number of different surgeries that are done by laser, okay, or are assisted by lasers. So if we name a few, eye surgery, it's regularly done using laser. Many people come and tell you that, okay, we have done this cataract operation, cataract surgery. How did they do it? They say, oh, we did it through LASIK. What is LASIK? This is a laser assisted process. Okay, so there are other type of surgeries that you can do with laser. Very regularly it is done, that is soft tissue surgery. Many occasions people have troubled ligament or tendons and all, and these are operated using lasers. There are various endoscopic surgeries. That are done using laser. Actually, as a matter of fact, this endoscopy process itself is done through laser. It's assisted by laser, and if you are going to do endoscopic surgery, many occasions you do it by using laser. So this is it's almost a kind of non-invasive process, and you do it little bit from outside. Okay. There are different other things, like I mentioned about non-invasive techniques. So regarding dermatology, so nowadays most of the dermatologic treatments are done through lasers. So in dermatology you find laser application. As I mentioned in the very first minute of this slide, laparoscopy is done using laser. There is something called photodynamic therapy. This is particularly used in case of removing or killing tumors or malignant cells like cancer cells. You use laser light to do the job. Okay, we might touch upon this particular part of photodynamic therapy during the application part, when we will talk about the applications. Okay, so there are many other types of applications in medical science that are there, and we are not going to talk about everything. What I am trying to do in this first class is to give you a glimpse of the areas where this can be applied. Okay, and some of this we will discuss in detail. And if we talk about industrial, so industry or commercial applications, you take simplest thing that you use every day, you find the application of laser. You take printouts of your papers or picture or anything. What do you use? You use a laser scanner. Okay, you read or write data in optical devices like CD or DVD, right? So there, what you use a laser to do the job. So this storing the data and retrieving it from that particular device is done by laser. So use it in CD, DVD. So this optical drives, storage devices. You use in reading the barcodes. Whenever you go to a market, a mall, you buy some stuff, and the shop owner will scan some area of the product where there will be some bars which contains the information regarding the price and other things, and that barcode is scanned by using laser. Okay, so these are very simple things that you come across every day. There are various other things that where laser is used. So in machining industry or engineering works, people need to cut and weld or pin metals in a large scale, right? So in steel industry, in railways industries, so you need to do cutting and welding and pinning, soldering, joining, various different things. So in every of each and every process that I just mentioned, for example, like cutting, welding, joining, okay, and then pinning, soldering. These are certain process where the metallurgist which metallurgists use very now and then, and in industry these are done in a large scale, and all these processes can be done using lasers. So there are now terms called laser cutting, laser welding, laser pinning, and so on. There are other type of processes where laser is regularly used, as cladding, drilling, so on. In case of macro machining or macro material processing, and even in micro material processing or micro machining, laser is very regularly used. They are used in additive manufacturing every now and then. There are certain other aspects which are very important for industry, particularly in space industry. So there is something called power beaming. So what is this power beaming? For the spacecraft, this power beaming through laser gives a possible solution to transfer energy to the climber of a space elevator. So you can imagine how important role that plays in the space industry itself. Okay, so there apart from this one, if you open any commercial website today, you will see there are various controlling devices, particularly remote controlling devices. Okay, so there you find the application of lasers. So laser is used in remote sensing devices, which are based on optical sensing mechanism. Apart from remote sensing, there are various other different types of detectors or sensors which are where laser is used. Another important area that many of you might be aware of is the area of optical communication. Where you need laser. Apart from that, on a lighter note, whenever you see some party going on or any musical program, you see something like laser show, okay, or laser display, and nowadays it is so common. Now just think about, there is no laser, there is no laser show, right? So I can go on and on by to tell you what are the different areas where laser have their functions. There is another important area which we'll just mention, that is in the area of defense or the military applications. Laser is being used as you know, as an ammunition. It is used, you know, to destroy objects or the weapons. So it's being used as a weapon. Okay. Apart from that, the defense industry use laser to you know, sense or detect threats coming in different form. That can be a missile, you know, or you know, that can be some intrusion at the border. So in all these cases, laser, you know, is used either to detect the threat or to eliminate the threat. So in military industry, usage of laser has gone up like super exponentially. Okay, we will not talk about military applications that much. So you know, by now I guess you were convinced that laser really has a vast application, okay, in various different sectors in your day-to-day life, everywhere. So if something has such a wide applicability, it won't be wise not to know at least the basic things about that particular topic or that particular device. In our case, that is laser. So we at least need to know something about this laser, and that is exactly what is our aim in this particular course, to learn some basics of this laser and to know about certain applications that this laser can have. So with this, I will conclude today's class, and we will meet in the following class with something you know, about the history of laser and some other stuffs. So till then, thank you very much.